Today, I'm going to talk about some likely topics that normally come out every year. I've been trying to check it from 2008 up to date. There are some topics that normally come out that you must read, and there's no how you not see question under it. That will be a kind of bonus to you if you get it. So these are the topics. Periodic table and trend, go and study it very well. It normally come out. Then acid base and salt, go and study it. It normally come out. Then chemical bonding, go and study this. It normally come out. Then organic chemistry 1 and 2, go and study it. It normally come out. Then stoichiometry, which is more concept, go and study all these topics. By the time you study, even if you study this one alone without any addition, there is no how you not have your success. So now, what I want to do today now, I would like to, because for me to take all this one by one, because this one is designed for like 2 years, 3 years, so I can't finish it with just 15 minutes or 20 minutes. So let me take this one, chemical bond, and you go and read. I will just summarize this one, because this one, as you are looking at this chemical bond, is one of the longest topics. If time permits me, if I can do it within 15 minutes, I can touch this one. But if I cannot touch it, just go to this one. Right? So chemical bond. Chemical bonding. So now, when we say chemical bonding, the word bonding, that something come together. So what is chemical bond? Chemical bond is the force of repulsion of attraction that make what a chemical or molecule to form. That is the force that attracts them together. Is called, whether it's force of repulsion or attraction, is called chemical bonding. Now we have different type of chemical bonding. We have what we call electrovalent bond. So we can also call it ionic bond. They can call it ionic bond. Then we also have covalent bond. So these two attributes bonds that normally come out in the WAEC. Now, let me add more. We can also have metallic bond. Now, let me try to explain this one after the other. What is covalent bond? Let me start from this one. Electrovalent bond, or you call it ionic bond. They can ask you to define covalent bond or ionic, or they can have the application. I will define one after the other, then application of this into the biological life. So now, electrovalent bond is the transferring of electron from one atom to another. Transferring of electron from one atom to another, usually from what positive to the negative charge. That is from the positive to electronegative. So meaning from metal to non-metal. So you can also say that. So electron has to transfer from one atom to another atom. That is what we call the electrovalent bond or ionic bond. But covalent bond is the sharing of electron between two or more atoms. When electron is shared, it's said to be what? It's said to be covalent bond. Then we also have what? Metallic bond. This metallic bond is the sharing of electron, a positive and electron, which is called the free radical with free electron attacking to what? Positive charge, which is called metallic bond. That is the bond between the metal, usually between two or more metal. That is what we call metallic bond. So let me now go back to electrovalent bond. The application, electrovalent bond, or we call it ionic. You can call it ionic bond. So let me explain. Now, I say is the process whereby electron being transferred from one atom to another, usually from the metallic to non-metallic, which is from metal to non-metal. Now, in this case, look at this one. How do we identify, before we now talk about the characteristics and what are those compounds that is fall under electrovalent bond? Look at this sodium. Let's say when you have sodium chloride, it's a compound because it contains sodium and chlorine. How do we identify whether it's electrovalent compound or covalent compound? How does it happen? So they can ask you after explain. After explanation, they can also say with what? With diagram. Now, or to dispute it. So now, if you look at this, sodium is 11. That is the proton number of sodium, or atomic number. You can also say atomic number. Then chlorine is proton number is 17, or atomic number of chlorine. So why must this one form? Let's see how it form. By bonding it to form. Now if you look at electroconfiguration of sodium is 11. I mean electroconfiguration of sodium is 281. Let me explain this one. The first electron, we have KLM shell. The first electron can occupy 2. So after the 2, it will jump to another electron, which is KL. It will jump to L. So L can take a maximum of electron of 8. After 8, the shell being full, it will transfer to another electron. So now, after this one full to 8. That's why you see 8 here. 8. So the last one has 1. That is the one you see outside. Now, chlorine, if you see that chlorine, which is called 2, 8, and we have 7. Now, what really happened here? If you look at this one critically, 281, then 287. Now, we say transfer of electron. Electron here will transfer of this to this, to add up to this. You can see I said from the positive to negative. Now, meaning that from metal to non-metal. Sodium is metal, while chlorine is non-metal according to my definition. So automatically the resulting bond will be 2, 8. And why this one will be 2, 8, 8. So it now result to electroconfiguration of neon. This is electroconfiguration of neon. Why this one is electroconfiguration of argon. If you have to explain why this one bond. So it will now have sodium chloride. This is the formula for sodium chloride. That is how it happens. Now let me now assume that you are asked to write the chemical, how the calcium chloride form. Let's say calcium chloride. How does it form? Calcium chloride. How does it form? So now let's try for calcium chloride. Calcium chloride. How does it form? Now if you see the calcium is 20, that is the proton number of calcium is 20, which is can also be atomic number. Then you have chlorine to be 17. Let's bond it. Let's find the chemical combination of this. Then we have 2, 8, 8. Then this is 18. Then having 2 outside. Then this one will be 2, 8, 7. Now if you look at this one critically, how can we say, because this one will tell us, this method, this is application of this, will tell you how to write the various chemical formula very well perfectly. Because in some cases they can ask you. That's why I say this one have many combinations. It is dry, more than dry in nature. You can use it to solve many things. So now, if they ask you what is calcium chloride, can we write the formula of calcium chloride? Is it right or wrong? At the end of this one, you know whether it is wrong or right. So now break this one into 2, because it can only transfer. This is only 1 to satisfy to become outer shell, that is 8. So it will now be 1 plus 1. So this one will transfer to this to make 1 plus 1 8, but it still have another extra ion outside, electron outside. So we now take another chlorine. Another chlorine will be 17, which is 2, 8, 7. So the last one will transfer to this to make 8. So now if you want to write the chemical formula of calcium, how it form, the chemical formula of calcium chloride, it will be calcium. How many calcium used is 1. How many chlorine used is 2. So that is the chemical formula of calcium chloride here. Calcium. So what is the essence? I will do one more before we now move to covalent bond. What is the essence of this particular? Is to know, you know the definition, we know the explanation, and it is also applicable in getting various. Because if you check they will say what is the chemical formula of, they can list like 3. I. You should list it out. This is how you can do it at the back of your paper to check. So let me now say, you want to know. I will do, okay, let me do 2 more. Let's say we want to know how this one form. The calcium and oxygen. So let's do it like 2, 8, 8, 2. Now, if you look at this one, now critically, we say 2, 6. Because the atomic number of oxygen is 11. The atomic number of calcium is 20. So now automatically we don't need any dose. This one and this one combine together to form 2, 8, 8, and this one will be 2. Sorry, 8. Okay. Now this is 2, 6. Sorry. This 2 plus 2 is 8. Oxygen is 8. Sorry. So now 2, 6. Now 2, 6. So now by the time you add this one, it will now be 2, 8, 2, 8 now. So 2, 8, because this 2 plus this 2 is 8. So the atomic is 8, and this one is what? Atomic number of is 20. So now we can easily write calcium oxide as this one. Now let's say this is chlorine. This is sodium now. This is sodium. Let's say for the sodium, let's try how the chemical formula of sodium and sodium oxide will look like. So sodium is 11, then oxygen is 8. Let's break it. 2, 8, 1. You can see this one. Now this one will give you 11. 8. So this one will be 2, 6. You can see this one. When you transfer this one, it's still 7. So it cannot be satisfied. So now you can write another sodium here. So it will now be 11. Break this one again. You now have 2, 8, 1. So this 2 plus 2 will combine to this to make 8. So it will now be 2, 8, and 2, 8. Now, how many sodium you use here? 2. The chemical formula will now be 2, 2, Na2. Then oxygen, only one oxygen here. So here you can know how to write chemical formula. Finally, let me write one more. Let's now say that it is between aluminium and chlorine. Let's say chlorine, aluminium and chlorine. Let's try this one, aluminium and chlorine. So now this one will be 13 is aluminium. Proton number of 13 is aluminium. Then proton number of chlorine is 7. Now 17. We have 2, 8, 3, and this one will be 2, 8, 7. Now if you look at this one has 3. So by the time it delivers this one here, this one will be 8. It will remain SR2. Call another chlorine here, 17 again. We have 2, 8, 7. So once you take another one here, it still remain 1. So chlor another chlorine, it will be 17, which is 2, 8, 7. So it will now be 1 plus 1 plus 1 plus 1. So this one transfer to this, this one transfer to this, this one transfer to this. So now it will now give us a 2, 8, 8, all to this one, 2, 8, 8. So this one will now give us 2, 8. Now in this case, so how many aluminium you use here is An. How many chlorine? 1, 2, 3, which is L2. So this is a 3. So this is the chemical formula of aluminium chloride, as you can see. So I hope that you can try many at home. So let me give you this one at home. Go and try aluminium oxide. Try it at home. You put the valency here. Just I'm giving you, whilst you are reading, go and try this one, and you can try more. Now let me now tell you the property. If they ask you, I will not be able to write this one. Let me just list it out. What is the property of any compound under covalent bond? They are conductor. Electrovalent bond or ionic bond, they usually be a conductor under electrovalent bond. Conductor, they can conduct electricity. They can also be a good conductor of heat as well. So they normally be a solid malleability, that they can easily turn, and lustrous, they normally shine. So these are the property of what you can add more because of time. So these I think I've given like 6 right now. I talk about conductivity of conductor of heat, conductor of electricity. They normally be a solid, and the malleability and lustrous. So like that. So now let me now talk about. Okay, I think that one. Let me stop here. Then covalent bond. Let me quickly talk about covalent bond. So which I've already talked about. Covalent bond. Now I said it by sharing. Let me tell you this one. It usually be metal. Non-metal versus metal, resolving its molecule. Now let me give you an example. Look at hydrogen. Hydrogen have a valence, one proton and 1 proton. Now by the time we have the shell, so look at this shell now. It has only 1 here. Another one has only 1 shell. Now, so by the time they form, it will form like what? this. We ask you to write it. So this one here combined to this one to form hydrogen what? Gas, which is one molecule, hydrogen molecule. Because one hydrogen is atom, one atom of and another one atom form hydrogen molecule. So you can see it has formed a bond, and this is what we list out as gas. So now let's now look at the chlorine. How do we form chlorine gas? Which is, you know, is molecule, it's non-metal plus non-metal, which is one atom plus one atom of what? One atom combined together to form this molecule. So this one, the first share, because it's 17 proton. So we have the first share to have this, another share to complete 8. So making 10. So the last one, okay, 17. This is 10. So we now have one year, and 1, 2, 3, 4, 5, 6. So the last one we here. So now let me draw this one again. I will not say, because it's the same thing. So let's say one outside. This is one outside. So one outside will now combine to this. It will now form hydrogen, chlorine molecule. So it will now form like this. I don't need to shade it again. Cross like this. So because of time, so this one and this one form together. Now we have more. So let me stop here. We have more that they combine together to form. Now before this one, now let me now talk about metallic bond. Now this is how metallic bond is. There is something called free radical or free electron. This positive, I'm talking about positive for metallic bond. Positive. You know, I told you that metal between metal, positive, and positive. There's something called free electron, which is electron here, electron that form electron cloud. We call it electron cloud. They have been localized. Localized is moving randomly. So if you now look at the law of electrostatistics, so this negative, this positive and positive will repel, and automatically the negative will attract. So this is how the metallic bond form. Is that taken? So after that one, I think if that one is all, so you can go further to read more because of the time. But let me talk about little thing about mole concept. Mole concept is just like formula. Now, when you are looking for the concentration that is under mole concept, I will talk about how you can get the relative molecular mass and the concentration of anything. So now, when we say relative molecular mass, just like I want to find the relative molecular mass of sodium hydroxide, they will give you this. They will say find the relative molecular mass of this sodium hydroxide. They give you this one. Now, after giving this one, they will say where N is equal to 23. So don't mind the rushing because of time. The oxygen is equal to 16 and hydrogen is equal to 1. Now, solving this one, I will start from this smaller to little bit complex. Solving this one now, we now say that you now say sodium. You now open bracket. What is the sodium? 23. You have 23. What is oxygen? 16. You have 16. Then plus what? Plus hydrogen. We have 1. Then we now have add everything together. This plus this is what? 24. 24 plus 16. That is this plus this. Okay. This plus this is 24. 24 plus 16, 40. 40. That is the relative molecular mass. So, relative molecular. But when they say the molecular mass of this, we can say gram per mole. So now let me give you one more. Let me now say, I will still come back to this. So let me say we are looking for calcium triazocarbonate. Let's say calcium triazocarbonate. Calcium triazocarbonate. Look at this one now. They can give you that calcium is 20. That is mass number of calcium 20. Yes, 40. Sorry. Then carbon is 12. Then oxygen is 16. That is the mass. Now, how do we now do this one? You open the bracket. The cation is 40, you write 40. Then carbon is 12, yes, plus 12. Then oxygen is 16. This 3 here is a 3 bracket 16. So you open the bracket. Then 40 plus 12 plus then 16 times 3 times 16, we have 48. So add everything together. 50. This is 50, 60. Then 60 plus 40 will give you 100. It's 100. Now, let me now tell you another question they can ask you under the mole concept here. Now, listen to another point. They can now ask you what is the percentage of so in that molecule. They can also ask you. Let me go back to sodium. What did I do the first one? Sodium hydroxide. Now, let me read because I didn't grab what I got that time. 23 plus 16 plus 1. So this is what I think is 40. Now they can say what is the percentage of oxygen in this particular compound. We just say the total number is called let me say the compound. Let me use the word compound over total. So times 100. Let me use this formula, percentage. So we now say this oxygen here is 16. So 16 all over 40 times 100. So now how do we do this? This one cancel this. Then 4 cancel here. We have 4. Then 4 times this, which is 40%. That is the 40% is the percentage of what oxygen in sodium hydroxide. They can ask you that. So grab this one because they normally ask all these calculations. That's why I wanted to skip it because I discovered that they can ask you. I want you to make sure because it's also long. I want to break it down. What of now calcium thiazocarbonate? The calcium thiazocarbonate, I will do in this form, 2 form. What is the percentage of oxygen in calcium thiazocarbonate? Now in this case, let's look at this one. Now O3. Let's look at it. O3, meaning that 3 times 16 here will give us 48. Now, what is the total number? The one I calculated before. Calcium thiazocarbonate is 100. Calcium thiazocarbonate is 100. So now, meaning that the number of reference we are talking about is 40, which is oxygen. Oxygen 3 all over CaCO3 times 100%. So which is equal to 48 all over 100 times 100. So 100 cancel 100, we have 48%. So these are what they can. So now after this one, let me move to another thing. Now after this one, let me move to another thing. They can say they dissolve. So let me just, I don't have question here. They can say calcium thiazocarbonate. Let's say 3 grams of calcium thiazocarbonate is dissolved in so. They can fabricate the question like dissolved in so that calculate the concentration of that calcium thiazocarbonate. They can. So now let me give you the concentration is equal to concentration is equal to mass all over molar mass, which we have done before. Molar mass of so. And we all know that molar mass of calcium thiazocarbonate that I just finished is 100 because I don't want to waste time. So now the mass is equal to 3. So concentration of it is equal to, we have mass concentration. This is what we call the mass concentration. So now then we now have the mass is 3. Then molar mass we've already calculated, which is equal to 100. So it will now be equal to this one divided by, we have 0.03 mole. Okay, gram. This is gram per mole. This is the answer in the shape form. So I will now go back to the concentration of the other one. Let's assume that the other one is 5. They said sodium hydroxide, 5 grams of sodium hydroxide dissolved in so. They will fabricate the question. That is why I'm giving you the formula. So that is you fabricate the concentration. So the 5 grams, when you take 5 grams, using your spatula to take 5 grams of this, you now dissolve it. So 5 grams. This is 5 grams of that sodium. So what is the concentration? The concentration is study about how the molecule of that in that particular mass. So now in this case, we now use the same thing that then concentration is equal to the mass all over molar mass. So I think that the molar mass we got here is 40. That times 40. So now it will now give us that 5 all over 40. We have 0. Let me add 0. Then this one, by the time you put so 2. So then like that, it will give you something like 0.12 because I did not take a calculator. So it will now give you gram per mole. It will give you gram per mole. So now let me tell you how they can even structure the. Okay, let me tell you how they can even structure. I think, okay, we have many things they can ask, but let me just stop it in this case. But before I stop you, they can ask you that what number of this that react, what number of this that, you know, 1 mole of something, 1 mole of Avogadro is equal to 6.02 times 10 raised to power 23. So in this mole, if they say what mass of so hydrogen that react, look at this one that react, look at the concentration, then call it S and divide it. So this is, I can stop here. Let me stop here so that because of time, just go and study all these things. I've broken that. When you go, you see more here. I've broken that. Just go and study all very well. But what I will tell you that there's a lot of things that I've sent. You check back. I've sent physics as well. We've sent physics online, so you should just go and check. And by tomorrow, by special grace of God, we send physics practical and other more. Don't forget, we are taking GSS 1 to GSS 3 for mathematics and other subjects, and SS 1 to SS 3 for other subjects, and we are also taking 100 level to 500 level. Don't forget to share, like, and comment. Thank you.